Hello and welcome to the AI Research Roundup. I'm Alex. It's May 6th, 2025. Alright, today we're looking at a research paper from Hugging Face's trending list, published about 9 days ago, called Generative AI for Character Animation. This paper offers a unified view on AI in animation, covering faces, gestures, and motion. It also discusses key models like denoising diffusion probabilistic models, or DDPMs, and neural radiance fields, NeurFs. Okay, so this first figure on page 3 really lays out the landscape. It shows how character animation is built from several distinct components, like facial animation, gestures, motion, and even generating textures or objects. The key takeaway here is that generative AI is enhancing each of these individual pieces, ultimately making the entire animation pipeline more efficient and the characters more realistic. Building on that, this next figure on page 5, figure 2, really dives deeper. It presents a taxonomy of recent advances in generative AI for character animation, organized by those key components we just talked about. So for things like face, expression, avatar, gesture, and even object and texture generation, it lists out specific models and methods. It's a great visual for seeing the breadth of tools now available. Alright, so this figure on page 9, figure 3, gives us a concrete example of one of these advanced models in action, specifically for facial reenactment. It shows a dual generator network. You can see it takes a reference face and a source face as input. The system then transfers the expression and pose from the reference to the source, while, crucially, preserving the source's identity. Pretty neat stuff. Now, moving to page 23, figure 10 illustrates a system called Dream Avatar. This is a really interesting architecture. It shows how text prompts, like Captain America, and SMPL parameters can drive avatar generation. You can see it uses an SMPL-based deformation field, a shared NeurF module, and then a diffusion model with landmark control net for refining the head. The goal is high-quality results with consistent facial features. So shifting focus to motion generation, this figure on page 37 presents Motion GPT. It's an architecture that uses a VAE and a large language model fine-tuned with LoRa to generate motion. You can see it takes a task prompt, like generate a sequence of motion tokens, and control conditions like text and pose tokens. The output is then a sequence of animated figures performing the described motion. Okay, now this next diagram on page 42, figure 16, shows us Dream Fusion, which is all about generating 3D objects from text prompts. So you can see it takes a prompt, like a DSLR photo of a peacock on a surfboard. It then trains a neural radiance field, or NeurF, from scratch for that specific caption. It also uses shading from normals and a frozen Imagen model to refine the geometry and appearance. So to wrap things up on this comprehensive survey, it's really clear that generative AI is profoundly changing character animation. We've seen how it's enhancing individual components, from facial reenactment to full 3D object generation. Ultimately, it's about making animation more efficient and achieving new levels of realism. That's our roundup for today. Thanks for joining me, and catch you next time.